All right, guys. So we're back from that break. I was asking Miss Way some just a little bit before the Zoom break. What is our HCF for this set of terms? So Miss Waysome, would you like
Yes, sir.
to share your answer with us?
Yes, sir. 3m square p square, sir.
So your HCF here is
3m square.
3m square
Yes, sir. P square.
p square. And so let us check that to see if you're on the right track. So for the numbers, the highest number that can go into 3, 6, and 24 would be 3. So for the number, the HCF is 3 numbers. For the letters, we look at what is common in all 3 of them. We say m is common. So we choose the lowest power of m to be m squared, correct? Look at the n. Would the n be common to all of them?
No, sir.
No. So we wouldn't choose the n, but the p is common to all of them. So we
Yes, sir.
choose what?
With the lowest power of p square.
So the lowest power of p would be p squared. So clearly then, our HCF here is just 3m squared p squared. Everybody see that? Let me see the hands if you are okay with this. Okay, good. All right, so we notice that only the factor 3m and p are common to all terms. So the lowest power of, m p would be to the power 2. And the 3 here we know would be the highest number for all the numbers. I can divide all of them. All right. So HCF would be 3m squared p squared. All right, here you go now. You have a little exercise here. I'll give you about 5 minutes to complete these. So just find the HCF of these for me. All right, guys. So as soon as you're finished with all 5, you just raise your hand to indicate to me. All right, guys. All right, Miss Nolok. You would have
Yes,
finished all three of them.
Yes, I'm not sure all is correct, but I tried all of them.
Okay. All right, so I just want you to do one. You want to do the first one?
Okay, sir.
All right, go ahead.
So I have P squared Q
E squared
Q
Q. Okay, P squared Q. All right. Can somebody else tell us whether or not they agree with Ms. Tulloch? Ms. Wilson, in agreement?
Yes, sir.
Okay. All right. All in agreement with Ms. Tulloch? Let me see your hands. All right. All right. Thanks much, Ms. Tulloch. Yeah, it would be, yes, it would be correct. So you choose common factors. P obviously is common in all the terms, and Q also is common in all the terms. So the lowest power of P, P squared, lowest power of Q, just Q. All right. Now, who else would want to go for the second one?
I'd like to try, sir.
Go ahead, Ms. Williams.
Sir, the answer is A square B square
A square, A square, B square. All right. Anybody else in agreement with Ms. Williams? Let me see your hand. Miss Green, are you in agreement with Ms. Williams?
Sir, I'm not sure, sir. May have A, B square.
Okay. Miss Williams? Miss Williams?
Yes, sir.
All
Yes,
right.
sir.
So we see that the A would be common in all of them, right?
Yes, sir.
But I want you to look closely at the one with the lowest power and tell me what you see.
So, sir, I'm seeing A that has no power,
Right. So that would be
and I'm seeing
that one would be
also
the lowest
A.
power, right?
Okay, yes, sir. Yes, sir.
When there's
Yes,
no
sir. That
when
would
there's
be
no
correct. A.
right, no power above it, it means that the power is one.
Yes, sir.
That means that you wouldn't have
It
an
will just be A.
all right. So for the A, it would be just the A.
Yes, sir.
So for the B now, B common to all three. So we would just take B
A
squared.
B square. Yes, sir.
That's AB squared.
Right, sir.
All right. Let me see the answer who are in agreement with this one. Who have gotten this?
Correct then, sir.
All right, good. Now, question 3. Ms. Cavero, you want to do question 3?
Yes, sir.
All right, go ahead and tell me what you get for your HCF.
Sir, I got 3 MN
3MN,
square, yeah.
MN square.
Yes, sir.
All right. Anybody else in agreement with Ms. Cavero? Let me call on somebody. Mr. Ojeno, are you in agreement with Ms. Cavero? Are you hearing me, Mr. Ojeno? All right, not hearing anything from Mr. Ojeno. Mr. Campbell, are you in agreement with Ms. Cavero?
I'm coming quite close to it, sir.
Okay, that means you don't have an answer yet.
I mean, I'm trying to rationalize it, but so what have you? Yeah, I would agree.
All right. Let me ask. Did I ask Ms. Green? Are you,
No, sir.
are you in agreement with Ms. Cavero?
Yes, sir.
Ms. Williams, are you in agreement,
Yes, sir.
Ms. Cavero? Let us check. So for the numbers, yes, 3 is okay. For the letters, what are common? M, common right through all the way, right? Lowest power of M is just M. Now, N is also common right through, but the lowest power of N here is what? Is it N squared?
No, sir.
No. So you got it correct the first time, Ms. Cavero. It's just 3mn. So you have to pay attention closely to the power. Now, how do you identify the power? Now, to identify the power, whatever letter you have to look above that letter to see if there's a number above it, immediately above the letter. If there's no number immediately above that letter to the right, then the power is 1. So if you notice, this n has the power 2, this n has the power 1, this n has the power 1. So please just take the time out to just check the power carefully to ensure that you find the HCF correctly, because if the HCF is not correct, then your factorization won't be correct. All right, moving along. Who else would like to give me the HCF for question 4?
May I try again, sir?
All right, Ms. Williams, go ahead.
Okay, sir. So when I look at it, I am seeing that B is common in all 3, but the lowest power is just B. So 7, 5, 2, and 7, there's no number that can divide all three numbers. So I think the answer is just B.
All right, is there anybody else in agreement with Ms. Williams? Okay. All right, Ms. Williams, checking it out. Yes, only B, which is common, and the lowest power of B is just B. Correct. Now, who wants to take the last one, question 5? Should I call on someone? All right, let me call on Miss Green. What's the HCF of this one, Miss Green?
Sir,
Yeah.
sir, with the part, sir, but for the number part, I have 3, sir.
Okay. All right. So Miss Green started it off with 3. Who would like to continue?
Me, sir.
Hold on. Let me write this properly. All right. Go ahead, Miss Cabrera.
Sir, it's 3XYZ.
3x, y, z. All right. So let us check. For the x, yes, the x's are all common. Lowest power of x is just x, correct. For the y is common to all of them. Lowest power of y is just y, correct. For the z is all common, yes. Lowest power of z is just z. Correct, Miss Cabrera. Very good. Thank you very much. All right, guys. So everybody got all of these correct. Let me see the hands of those who got all of these correct.
Sir, I have for number 4, I had 1B. So
all right. So the one there would be redundant because in math, when we don't have any, when we have 1 in front, any unknown, if you multiply it by the 1, you just get back the same unknown. So we don't generally put the 1 in front of a single unknown or any unknown at all. We don't put the 1 as a coefficient. The 1 remains invisible for those unknown where 1 is the coefficient. All right. And so when you write the 1, we say that that is mathematically naive, meaning that if you write 1, it is only saying to us that you would not have, see the idea that you don't have to put the 1 in. So rather than putting 1, it is understood that without the 1, it is still the same number. So it's just a way of we would like to write algebra so that we can somewhat make it look simpler. So rather than writing 1b, 1 times b going to give you about b, you just simply write b. Now for any other number other than 1, we need to put the number. All right. All right, guys. So I think everybody is good so far. And I hope you would have grasped the concept of finding HCF, and you would have gotten an idea of how you factorize by HCF. We're going to stop here now for this class, but when we meet again, we're going to continue with factorization with the HCF method. So we're going to look at some more examples in terms of factorizing with the HCF method. But the important thing is, 1, you're able to identify HCF for unknowns, because you have to be able to do that in order to do it correctly, to factorize correctly, that is. All right, so I'm going to stop here, guys. So let me go back here.